What's the signage industry? Need for a printer. Due to the characteristics of thermoplastic materials, thermal expansion and contraction inevitably occur during the heating and cooling cycles, leading to warping and deformation of printed objects. To ensure repeatability in signage production, the absolute printing success rate must be considered when using FDM printing technology for signage manufacturing. The definitions and inspection criteria for a successful print are as follows. Bottom warpage is less than or equal to 1 millimeter. Wall warpage is less than or equal to 1 millimeter. Acrylic and step are assembled without gaps. To ensure a high print success rate, you must understand the following parameters. Flow rate. Flow rate in FDM 3D printing refers to the amount of filament actually extruded, compared to the calculated amount. Adjusting the flow rate helps control extrusion accuracy, improves layer adhesion, and prevents issues like over or under extrusion. How to adjust the flow rate ratio? We can print a test model according to the calibration guide in the slicing software and determine an optimal value by evaluating the printing results. Volumetric flow rate. In 3D printing, volumetric flow rate refers to total volume of material extruded through the nozzle per unit of time. It reflects the actual extrusion speed of the printing material and is a critical parameter affecting print quality and speed. If the volumetric flow rate is too high, it may cause overextrusion or nozzle clogging. If it is too low, it may lead to underextrusion or weak layer bonding. Therefore, properly setting the volumetric flow rate is essential for achieving high-quality 3D prints. The volumetric flow rate can be optimized by adjusting parameters such as print speed, nozzle diameter, and layer height. Layer height, the thickness of each printed layer, affecting printing speed and model accuracy. Print speed, the speed at which the print head moves, influencing print quality and efficiency. Bed temperature, the temperature of the printing bed, impacting the adhesion of the printed material. Retraction settings, used to prevent stringing and oozing of filaments. Shell and top of bottom layer thickness, affects the surface quality and strength of printed parts. Printing template. By integrating all the above parameters and tailoring them to our indoor and outdoor filaments, we have developed specialized printing templates, which have been validated through tens of thousands of printing tests. Of course, there are many detailed parameters that affect print quality. Let's dive in and master 3D printing together.